Hello boys and girls, welcome to Jabulani's Playhouse. I'm Jabu, and I'm Lani, and we got some fun toys today, don't we, Jabu? We sure do. This is something we've never done before. This is Lab in a Bag Test Tube Discoveries by Be Amazing Toys. Should be fun, hey? It should be, Jabu. No, we haven't done this before, and I don't think either of us are very good chemists or scientists, right? I know, but hopefully these instructions will help us, and we'll be able to do a fine job, hey? Well, let's check it out and see if we can do it. You betcha. Okay, there's an overview. And you can see this is safety tested, lab in a bag, test tube discoveries. Do more than 15 activities. Wow, Jabu, that's quite a lot, hey? It is quite a lot, hey? And it's for boys and girls ages 8+. By Be Amazing Toys, you can grow fake ice cubes, make your own pH indicator, make your own lava lamp, create gravity goo. Wow, Jabu, that sounds like a lot of fun. I know, look at all the stuff in here, hey? The set contains chemicals that may be harmful if misused, so of course you always want to be careful. That's right, Jabu. And there's the test tubes. Create gravity goo. Make your own lava lamp. Grow fake ice cubes. Lots of fun, hey? There's the activities. That's what it all comes with. Make your own lava lamp. Grow fake ice cubes. Grow giant bouncing marbles. Create gravity goo. Contents 5 giant plastic test tubes with lids, 1 plastic test tube holder, 5 grams of large clear cubes, 5 grams of garbled marbles, 10 grams of gravity goo powder, 2 grams of pH indicator powder, 3 true colors, tablets, 1 plastic pipette, 4 pH paper strips, and instructions. Yay, Jabu! Yeah. And that's all in French, I think. Cool. This is the back, yeah, and the back is in French too. Let's open it up, hey? Yeah, please. I have to cut this off though. Excellent. Let's see what's in here. Wow. The whole thing will come out. Put the bag over here. Take this off. And there we have it. Okay, look at all the stuff we've got in here too. Very tricky chemicals. We've got to be careful with that. We won't open that just yet. Take a look at the instructions. Let's put that a bit further away. Give us some room here. Wow, there's lots of instructions here. Let's open up the first one, see what this says. The world's greatest test tube. Scientists use test tubes of all different sizes and shapes to collect and study really cool things. A test tube can hold a liquid like water. A test tube can be used to collect a sample of water from a river. A chemist uses a test tube to study chemicals. Scientists put dirt, leaves, sticks, rocks, even bugs in a test tube. But you should never put food in a test tube. The test tube might not be clean. So what makes these test tubes so great? Most test tubes are made out of glass. This test tube looks like it is made out of glass, but it's really plastic. But there's something else special about this test tube. What are those grooves on the top? It kind of looks like the top of a bottle. A plastic 2-liter soda bottle, to be exact. Drum roll, please. The world's greatest test tube is really a baby soda bottle. That's right, your test tube is modeled after a plastic 2-liter soda bottle before it is blown up into a big bottle. The plastic test tube is placed into a mold and heated. Then very hot air is blown into the test tube. This makes the plastic stretch like a balloon and fills the inside of the mold. The test tube grows about 40 times its original size. When the plastic cools, the mold is opened and the bottle falls out. Wow, Jabu! Yeah, we can see that. We can see that this is like a bottle cap, right? Exactly. Wow, that's cool. And it does grow into, and this is how they make soda bottles, I guess, hey? Wow, Jabu, that's crazy. Okay. Each test tube contains a different set of science experiments. Just empty the contents of each experiment and follow the instructions. And there's some warnings, of course. After you've finished with each experiment, you might be wondering what else to do with your test tubes. Here are just a few ideas to get you thinking. A discovery tube. Use the test tube to collect all sorts of goodies on your next nature walk. Use the test tubes to collect dirt samples, leaves, or good old bugs. Liquid laboratory. Use the test tubes to collect samples of water from ponds and streams to study later using a magnifying glass or microscope. Roots with a view. Grow a plant in the test tube and see the roots sprout. Learn about root simply replacing dirt inside the test tube along with a few seeds. Try growing grass, radishes, or whatever you desire to learn how plants develop and the roots search for water and nutrients. Time capsule. Use the test tube to hide a secret message or as a way to store information that will be opened sometime in the future. Make your own twister. Fill the test tube 3/4 full with water and add a few drops of liquid soap. Seal the bottle with a cap and start twisting. The swirling motion of the soap and water will make a twisting, turning vortex. It's your very own pet tornado. Dancing beads. Fill the bottle half full with small styrofoam beads, like those found in beanbag chairs. Add water until the beads begin to overflow the bottle. Seal with a cap and watch the styrofoam beads jockey for position in the bottle. Sands of time. Place layer after layer of various colors of sand in the test tube to make a colorful rainbow. That's a good one, Jabu. I know it would be, hey? There's even some more ideas. The marble challenge. Fill the test tube 3/4 full with sand and place a marble on top of the sand. Seal the tube and try to find a way to move the marble from one end of the bottle to the other as quickly as possible. Make 2 or 3 and challenge your friends. Flower holder. Fill the test tube half full with water and use it as a flower vase. It will stand up if you put it into the lid. That's a clever idea, Jabu. Yeah, so if you stand it up like this, you can put it on here. You can see it stands up. Wow, that's clever. Yeah, it is. Excellent. Lots of fun. Rain gauge. Use permanent pen and a ruler to mark off half-inch increments on the test tube. Put the tube in an open area outdoors to collect and measure rainfall. Message in a bottle. Place a message in the test tube and seal it with a cap to make it watertight. Float the message in a bottle to a friend across the pool. That's a good idea, Jabu. We don't want to put it in the ocean, right? No, because then it just creates like garbage, plastic, right? And it might not make it to the other side, right? So it's best not to put it in the ocean. Pop goes the weasel. Find a cork that fits snugly into the opening of the test tube. Fill the bottle 1/4 full with water. Divide an Alka-Seltzer tablet into quarters and drop one section into the tube. Quickly seal the test tube with the cork and point the corked end away from anything living. Pow! The cork goes sailing. That's a good one, Jabu. It sure is. Travel containers. Fill the test tubes with your favorite soap, shampoo, conditioner, hair gel, hand lotion, sunscreen, or whatever else makes you happy for your next vacation. A glitter wand. Fill the test tube 3/4 with cooking oil and add an assortment of colored beads, glitter, and mylar confetti. Top the tube off with cooking oil and seal with a cap. Tip the tube back and forth to make your glitter wand sparkle. Magnifying glass. Fill the test tube to the very top with water and seal it with a cap. Hold the test tube up against newspaper print to magnify the letters. The water magnifies the message. Rhythm tube. Fill the test tube with an assortment of beads, pebbles, nuts, bolts, you name it. Seal with a cap and start shaking. Experiment with different materials. Each will make its own unique sound. Color mixing with your eyes. Fill 3 test tubes almost to the top with water. Add 2 drops of blue food coloring to one test tube and seal it with a cap. Do the same with the other 2 using yellow and red food coloring. Hold each test tube up to your eyes near the light to observe the color. Now cross the yellow and blue tubes in front of your eyes, looking through both of them at the same time. What color do you see? Green? Cross the red and blue tubes in a similar fashion to make purple. What color does red and yellow make? Wow, Jabu, that's crazy. Yeah. Who can we blame for these ideas? This is the guy, Steve Spangler. Steve Spangler's Science. That's because he created this activity guide. He's actually a cross between a scientist, a magician, and a kindergartner who really wants to explore the world. Steve brought us his crazy ideas for using baby soda bottles and made them a mess of our office with his inventions. We sent him back to his laboratory in Inglewood, Colorado, where he's probably working on another idea to get people of all ages turned on to science. That's fun, Jabu. Yeah, that's a good one. There's lots of stuff in here. What is this? Is this all French, maybe? This looks like it's all French, I think. Yeah. I think it's all French. Yep, this is all French. Cool. Glad they have it in French. And this is also French, which gives you the different ideas for what to do, right? That's right, Jabu, that's what we just read. Excellent. Which means, boys and girls, that what we need to do when we come back tomorrow, we'll start off with which one, Lani? Let's do the one in the middle first. Aha, so we're going to start off with this one. Ooh, this is disappearing jelly ice. Learn more about the incredible science of the super absorbent polymer as you grow, blah, 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 blah. So we'll come back tomorrow and we'll start with this one. So we'll leave that one out there for now so we know which one to start with, right, Lani? That's right, Jabu. So come on back tomorrow, boys and girls, and Jabu and Lani are going to become mad scientists, right? We sure are. Puppy mad scientists. It's going to be a lot of fun. We haven't had this fun before, but I think it's going to be super fun, hey? I think so. It's going to be fun to do all sorts of science experiments. I know a lot of boys and girls out there want to become scientists when they grow up, right? Exactly. Scientists do a lot of good work in the world, so we thank them for their services, right? That's right. They make our lives easier in many ways, right? Exactly. Well, thanks for joining us, boys and girls, and remember to always play safe when you're dealing with chemicals and have mommy's and daddy's supervision, right? That's right, Jabu, and we'll see you again next time. Bye-bye. Bye for now. Hello, boys and girls. Welcome to Jabulani's Playhouse. I'm Jabu, and I'm Lani, and Jabu, we have a problem, Jabu. What's that, Lani? It looks like somebody stole our disappearing jelly ice. Oh no, do you think so? Well, I can't see it in the bowl when we put it in the water yesterday. We could see it, but now it's gone. Well, let's take a closer look and see if we can uncover the puzzle, the mystery of this disappearing jelly ice. Okay, let's find it, please. Okay, so there's our bowl of water, and you're right, Lani. It looks like the jelly ice has disappeared, but I don't think it was stolen. I think it was part of the disappearing act, like we said. Let's see if we can find it. Okay, Lani, we have a little scoop here. Let's see if we can find it. Oh, look at that, Lani. Oh, Jabu, it hasn't disappeared at all. There it is. Let's take a close-up look. Yeah. Well, look at that, hey? Wow, and it feels, ooh, whoops, feels spongy. I broke it by mistake. That's okay. It feels spongy, doesn't it? And look how much bigger it is now. Wow, that's huge, hey? Let's get our measuring tape and see. Okay, so we said they were about 1.5 centimeters last time. Now it's about 6 centimeters, I guess. Wow, Jabu, that's crazy. Is there another one in there? Because we put 2 in. I think there are, Lani. I think here's the other one. Wow. Wow, Jabu, this is crazy. I really thought it had been stolen. I thought it had disappeared or somebody had taken it. No, nobody's taken it, Lani. Let's see how big this one is. Wow, this one's about 5 centimeters. They grow pretty big, hey? They sure do, Jabu. That's crazy. And now you put it in the water, and it's disappeared again. Wow, Jabu, that is crazy. That was cool, hey? It sure is. Let's see a bird's eye view of see if we can see it inside the water and then bring it out. Okay, can you see the jelly ice? I can't, Jabu. I can't see it at all. Well, let's scoop in here and see if we can find a piece. There, now you can see it. There it is. Wow, Jabu, crazy. And we put it back in. It just disappears. I know. Let's see if we can find another piece. Here's the other pieces. There's a piece. Wow, Jabu. That's crazy. I can't believe it. We put it back in and it just disappears. I know. That's terrific, hey? It sure is. Wow, Jabu, I really thought it had gone missing. I know, it's hard to see, isn't it, hey? It sure is. I imagine if we had used blue color dye, we might have been able to see it better, right? Exactly. But this was more fun. It looked like it disappeared. That's why it's called the disappearing jelly ice. And that was a lot of fun, wasn't it? It sure was, Jabu. I loved it. It grew very big, didn't it? It did. It grew very large, and it was amazing and quite firm still as well. So that was a lot of fun, and we got more disappearing jelly for next time, right? That's right, we can do some more of these experiments. But tomorrow, boys and girls, coming back, we'll choose another of our test tubes and do another experiment, a different one, right? Exactly, it should be a lot of fun. Thanks for joining us. Hope you're having fun with us. We sure are. We sure are, Jabu. Chemicals and science experiments are a lot of fun, right? Exactly, but always remember to take caution and to use your safety goggles and all these sorts of things, and maybe wear gloves and have mommy or daddy to help you, right? That's right, Jabu. Bye-bye. Bye for now. Hello, boys and girls. Welcome to Jabulani's Playhouse. I'm Lani. And I'm Jabu. And we're having fun with our lab in a bag. These are science experiments, test tube experiments, and it's a lot of fun, isn't it? It sure is, Jabu. We've done a whole bunch of ones different so far. Well, we only did the one, I should say, right? Yeah, that's right, but we've got a whole bunch to do. I think that's what you meant, hey? That's right, we got another 4 experiments to try, so shall we get to it? I think we should. Which one do you want to choose first? Well, let's try start from the left this time, hey? Okay, sounds good. Let's get to it. Okay, and this one, as you can see, boys and girls, this was the test tube where we did the disappearing jelly ice. And this was the one here, disappearing jelly ice. We did that, and that was a lot of fun. And now we're going to choose the one on the left. And what's this one, I wonder? This is pH Fun. Make your own pH indicator. Explore the science of acids and bases as you study things found in your own kitchen. Okay, Jabu, let's get to it. Okay, we have to take this out here. Whoops, there was something in there. Oh, I think these are pH strips, hey? Alright, close this up. Boys and girls know these are just little pop bottles, soda pop bottles, before they get changed into big soda pop bottles for 2-liter pop, hey? That's right, Jabu. Okay, let's have a read here then. See what this one is all about. pH Fun. Make your own pH indicator. Explore the science of acids and bases as you study things found in your own kitchen. And of course, these are chemicals warnings, so you got to be careful and get your mummies and daddies to help if you're following along at home, right? That's right, Jabu. Okay, from the kit, we have pH indicator, red cabbage juice powder, pipette, pH indicator strips, and test tube. You get it stuff. Okay, so we need a notebook and pencil, which we're not really following on because this is just for demonstration, right? That's right, Jabu. And we need 5 small paper cups, Q-tips, test liquids from the kitchen, including lemon juice, clear sports drinks such as Gatorade, vinegar, window cleaner, and lemon lime soda. Well, we got some of those we can do. And water and baking soda or powdered detergent. Excellent. Okay. Before you start, you will be doing real chemistry using things from your own kitchen. Be sure to keep a close watch over your adult helper. Make sure your helper knows that the liquids you will be testing, things like vinegar, lemon juice, window cleaner, and baking soda water, should be used with care. Have you ever gotten shampoo in your eyes in the shower? It stings. Tell your adult helper not to touch their eyes, ears, nose, or mouth after handling these liquids until after they've washed their hands, and wear safety goggles if you have them. Work with your helper to find a place to set up your lab where it's okay to spill a little, and to find a place to set up, where it's okay to spill a little, and where your experiments won't be disturbed by pets, babies, or other wandering adults. If your helper's eyes do get something splashed in them, they should be flushed thoroughly with water for 15 minutes. If they are still uncomfortable, contact a doctor. Okay, that's good to know, Jabu. It is. Are you ready for some fun? The explanation of acids and bases described in this kit is based on the studies and explanations of a Swedish chemist named Svante Arrhenius, who studied acids and bases in the 1890s. Other scientists have come up with different theories about the chemistry of acids and bases. You will learn about these theories in school someday. For now, if some snooty scientist tries to argue with you about what acids and bases are, just tell them, I see you are a fan of the Bronsted-Lewis definition. Let's just keep it simple, shall we? I don't want to confuse my parents. Hee Jabu, that's funny. So what are acids and bases? I don't know, Jabu. Well, let's find out. Have you ever heard someone say H2O when they were talking about water? The H stands for hydrogen and the O stands for oxygen. Each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom stuck together. You could think of a water molecule as a little Mickey Mouse face with one big oxygen head and two little hydrogen ears. Water molecules have a tendency to come apart. Scientists would say they dissociate and then come together again. When they come apart, one of the hydrogen atoms comes away from the rest of the molecule, so instead of having HOH, there is an H and an OH. In other words, there is a lonely ear and a one-eared Mickey. When there are more H's than OH's, more lonely ears than the one-eared Mickeys, scientists say the water is acidic. When there is more OH's, more one-eared Mickeys, the water is basic. But where did the extra ions, H's or OH's, come from? Some other molecules come apart when they are mixed into water. If the pieces they break into are H or OH, or act like they are H or OH, scientists say they have made the water acidic or basic. This is very interesting, Jabu, and quite complicated. It is, isn't it, Lani? There are different kinds of acids and bases. You probably already know some of them. Although all acids act alike and all bases act alike, some are stronger than others. Scientists created a way to measure how acidic or basic something is. The measurement is called the pH, which stands for potential for hydrogen. A liquid can have a measurement anywhere from 0 to 14. Something with a low pH, 1 or 2, is very acidic. Something with a high pH, 12 or 13, is very basic. Water is neutral, neither an acid nor a base, so it has a pH right in the middle, around 7. Cool, Jabu, that's good to know. There are different ways of testing whether something is an acid or a base. One way is with an instrument called a pH meter. One of the easiest and best ways, though, uses a special kind of paper that changes color when it comes in contact with something that is acidic or basic. The paper is called pH paper and has one or more chemicals on it called pH indicators. You have some pH paper strips in your kit. Are you ready for some detective work? I am, Jabu, and these are the pH paper strips, right? I think they are. Okay, let's try it. Use the pH strips in your kit to test things in your kitchen. Work with your adult assistant to find things you can use to discover pH. Here are some things you might want to try: water, vinegar, soda pop, window cleaner, lemon juice, salt water, milk, and baking soda water. Stir a little baking soda into a cup of warm water. What else can you think of to try? Once you have decided what you will be testing, write down all of the test subjects in your notebook along with your guesses as to whether they are acids or bases. To test the liquid, either pipette a drop onto the pH strip or dip a Q-tip into the liquid, dab off the excess on a paper towel, and then tap the Q-tip lightly on the pH strip. If the liquid turns the strip red, the liquid is an acid. If the liquid turns the strip blue, the liquid is a base. If the strip stays yellow, then the liquid has a neutral pH. What do you see? Write down your observations in your notebook. Were you right? How does it work? A pH indicator is a chemical that changes its structure when it comes in contact with an acid or base. When it changes its structure, it also changes color. Scientists use the color changing ability of indicators to figure out the pH of different liquids every day. You just did real science and excellent detective work. You are amazing. Jabu, that's terrific. Okay, the secret of red cabbage juice. Another way of testing for acids or bases is by using a pH indicator solution. You can try it. Fill an empty test tube with water. It holds about 50 milliliters. Pour the water into an empty cup and add half the bag of your pH indicator powder and stir well. Your powder is actually an extract of red cabbage, which contains a natural pH indicator, a pigment molecule called flavin, and anthocyanin. Pour about 2 teaspoons, 10 milliliters of each test liquid into a separate paper cup. To each cup, add half teaspoon of your red pH cabbage juice indicator. Now watch for the color changes. If the substance is an acid, such as lemon juice, the indicator should turn bright pink. If the substance is neutral, sports drink, then the indicator should remain reddish purple. Finally, if the substance is a base, like window cleaner, then the indicator should turn greenish yellow. Other things to try. Make your own pH paper strips by using your red cabbage indicator. Take filter paper or a coffee filter and soak it in concentrated red cabbage juice solution. After a few hours, remove the paper and allow it to dry. Hang it up by a clothespin or a string. Cut Cut the filter paper into strips and use them to test the pH of various household items, just as you did with pH paper strips that came in your kit. Red cabbage indicator colors. If the color is red, it has a pH of about 2, which means it's acidic, right? That's right, Jabu? And purple is also acidic at 4. Violet is almost roughly neutral. That's right. And then we get into blue, and that becomes basic. And then 10, blue, green, 12, greenish, yellow, super basic. Wow, Jabu, this is a lot to try. Let's get our stuff ready. Okay, Lani. So we have just 3 glasses out here because we couldn't find all the different things, but we thought this would give us a nice sample of things to try. So on the left we have orange juice. That should be an acid. And then in the middle we have water. And then on the right hand side we have a base, which is a window cleaner, right? So that should show us the different types, right? So let's see if we can maybe use, we'll be careful. So we'll break these into halves so we get 2. So let's try the acid, which is orange juice, and the acid should turn red, right? Should turn the paper red. Let's see if that happens. I would say it does a little bit. Hey, what do you think, Lani? It does. It kind of going orange, which is going closer to red, right? Yeah. So let's put that down there and see what happens. Well, let's put that up there like so. And let's see what happens when we put it in the water. Ah, the water's kind of going bluish. You can see, which means that the water here where we live, I guess, is a little bit more basic rather than neutral, right? That's right, Jabu. That's very interesting. I guess pure water would be neutral, right? Like distilled water, maybe. Yeah, I think you're right. Okay. And now let's try this. This should also turn blue, even though it is blue, but wow, it turns very blue. You can see, hey? So this is quite basic. Wow, that's neat. Wow, Jabu, this is a good experiment, eh? It is. Okay, so what else we're going to do is we're going to take our pipette and we're going to put in drops of cabbage water, right? Because remember they said, this is a little pipette, I guess, or dropper, I should say. And I guess they said we could take the cabbage powder, which is here. Let's see if we can get it out. Here we go. We've got one last little thing here with a couple of little pills in there. That'll be interesting to see what we do with that one. So we'll take this and we'll fill this up with water. Then we'll mix in half of this cabbage powder here. And it says a pH indicator powder. So let's try it. Okay, Lani, so I think we're ready here. All right, Jabu, let's do it. Now we've got our cabbage powder, which we mixed in with water. Some of it was a bit hard. Couldn't mix it too much. As you can see, there's a little bit of a firm ball of cabbage powder in there, but we'll do our best. It looks pretty dark. So let's see what it says again. Let's just to confirm. It was a good idea when you're a scientist just to confirm what you need to do. So let's see here. Okay, the secret of red cabbage juice. Alright, so pour about 2 teaspoons of each test liquid into a separate paper cup. So we just have a little bit of liquid in the paper, not our paper cups, but in our glass cups there. And then to each cup add half a teaspoon of your red pH cabbage juice indicator. So let's see, and then these are the colors it should go, if it's acidic or basic. So let's try it. Yay, Jabu! Okay, so I think this says 1 milliliter up to that little ball here to the top right. So let's try that. Okay, try orange juice first. We'll go from left to right like we did before. Okay, let's see what happens. Maybe add a drop more. Okay, let's swirl it around, see what color it goes. Yeah, so it is kind of going a pinkish red. So I guess that is acidic, as we know, right? Because remember here it said if it's red, a pH of 2, and 4 is purple, so it's kind of like pinkish red, so it's definitely acidic. Now let's try the water, and we thought the water was basic, right, Lani? That's right, Jabu. Okay. Add a drop more. So what color do you think that is? That's kind of reddish. It's kind of the same color, so I guess it is neutral. Not sure why it went bluish last time, but that's interesting. And now this next one, even though maybe we chose the wrong window cleaner because we chose one that's colored blue, but we couldn't help that, could we, Lani? But you can see this one's going even darker blue, so it's kind of definitely like a purpley blue, so that's definitely basic. Let's give it a swirl. Okay, and let's take an overview so the boys and girls can see it better, right? That's right, Jabu, let's take a look. Okay, there you go, boys and girls. So here you can see the orange juice slightly pinkish, so definitely acidic. Then the water stayed the same color as the, we should put something white underneath, eh? So you can see definitely sort of same color of cabbage, so that's certainly sort of neutral. And then when we put the window cleaner on, you can see it's definitely got a dark sort of blue, so it's definitely basic, right? That's right, Jabu, let's look at the orange juice again. Okay, there you go. Now you can see the orange juice color's kind of got a hint, a tinge of sort of pinkish, orangish red, so definitely acidic, hey? Yay, Jabu! That was a lot of fun, Jabu. I loved it. Me too. It was a lot of fun. It was pH, fun with a PH. PHUN. Jabu, that's right. It's a lot of fun. And it was fun science experiments with pH, which is a indicator of acidic or base, right? Exactly. We did orange juice, water, and window cleaner. There's a whole bunch of others you could try at home if you wanted to, boys and girls. You can follow the instructions. This is a lot of fun. It's a lot of cool things you can do in this lab bag, right? That's right, Jabu. We're having a ton of fun. Hope you like it too, boys and girls. Come back tomorrow. We'll do some more. We sure will. Miss you until then. See you next time. Bye-bye for now. Bye-bye. Hello, boys and girls. Welcome to Jabulani's Playhouse. I'm Jabu, and I'm Lani, and today we're going to continue on with our test tube lab, right? Our lab in a bag. That's right, these are test tube adventures. It's a lot of fun, and today we're going to start with number 3, our third test tube, and see what sort of experiments we can do in there, hey? That's right, Jabu. We're mad scientists, aren't we? We sure are. Let's have some fun. Okay, so on the first day, the boys and girls know, we did disappearing jelly ice, which was a lot of fun. And then yesterday we did pH fun, which was also a lot of fun with pH. Jabu, I know, that's crazy. All right, so now we're going to use the second one over here. You can see, and what's this one? Ooh, this is Gravy Goo, science experiment in a tube. Ooey gooey fun. That looks like fun, Jabu. Let's check it out. Okay, we'll open it up. Ooh, there's some stuff in there, as you can see, boys and girls. Try and get it out here. Aha, this is empty. There's something in here. Ooh, look at that stuff. Looks like sand or something, hey, or sugar or salt. It does, Jabu. That's crazy. What does it say? This is gravity goo powder, which is linear polyacrylamide. Wow, fun. Okay, let's see what it says here, Lani. Gravy Goo, science experiment in the tube. Ooey gooey fun. And then the warning, of course, so we'll pay attention to that. What you'll need from the test tube. A blue scoop, Gravy Goo powder packet. Optional, several beads from the Garbled marbles test tube in your kit. You get it stuff. Water, 2 large transparent disposable cups, paper towel, plastic spoon or popsicle stick for stirring, and food coloring optional. We don't have food coloring, I don't think, but we'll take a look. You'll be pouring liquids back and forth between 2 cups in this experiment, so work with your adult assistant to find a place to set up your laboratory where it's okay to spill a little. You'll need to pour the liquid back and forth continually for nearly 10 minutes, so you may want to get your adult assistant to stand by to trade off with you in case you get tired. If your assistant complains, tell them to hang in there. It will be worth it. That's interesting, Jabu. Okay, so let's try it. This is what we do. Fill 1 cup with 16 ounces of room temperature water. Use the blue scoop to measure out 1 level scoop of gravy goo and pour it into a 2nd cup. Be careful not to inhale the powder. The polymer powder is not toxic, but inhaling any powder could be uncomfortable and will make you cough. And after all, you want to goo in the cups and not in your nose. Have you ever seen a movie with a mad scientist who pours something back and forth between 2 beakers? Believe it or not, that's just what this experiment needs now. Pour the liquid from the 1st cup to the 2nd cup. Use the plastic spoon to stir it gently and then pour everything back into the 1st cup. Keep pouring the liquid back and forth from cup to cup. For the first 2 minutes, you'll need to pour fairly quickly to keep the goo from clumping. If you do get clumps, or if the powder sticks to the bottom of the cup, gently stir the liquid again. If the clumps won't break up, let the mixture sit for 24 hours to allow the lumps to dissipate. After 2 to 3 minutes of pouring, the liquid should start to form. After 2 to 3 minutes of pouring, the liquid should start to form strings of goo as you pour it back and forth. Once you see the strings, you can start pouring more slowly, but you'll need to keep pouring for about 5 more minutes. Feel free to practice your maniacal mad scientist laugh. Ha 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 ha! Mwahaha! Jabu, that's silly. I know, we're just having fun. You are probably pretty tired now, right? For the next step, you need to take a break. Your gravy goo does too. Pour it into 1 cup and let it sit for 30 to 40 minutes. Now your gravy goo is ready. Let's try an experiment in anti-gravity. Warning, your gravy goo washes easily off your hands, but it is harder to wash off clothes and carpet. So work with your adult assistant to find a good place to do this next experiment. Let's see what the next experiment is. Start pouring the liquid between the 2 cups again. Make sure you keep the cup you are pouring from higher than the cup you are pouring into. After you've poured the liquid back and forth a couple of times, you will notice something strange. Once you start to pour the liquid, you can't stop it. It crawls up and over the sides of the cup by itself. Why is that? A new alien life form? An anti-gravity slime system? A magic trick? Better, it's science. How does it work? Like garbled marbles and disappearing jelly ice, gravy goo science is the science of polymers. Have you done those experiments yet? We did, Jabu, we did the disappearing jelly ice, but we haven't done garbled marbles, have we? No, not yet. Gravy goo is a unique kind of polymer made of 2 smaller pieces, monomers. One kind, polyacrylamide, acts like a sponge and soaks up water. The other kind, acrylate, links long strings of molecules together. While your garbled marbles and disappearing jelly ice are like big nets, you could imagine that your gravy goo is like a big bowl of spaghetti noodles. Imagine a bowl full of spaghetti noodles that are partly hooked together. When you pour your gravy goo from 1 cup to another, it's like you grabbed onto one of the noodles and started pulling out of the bowl. Since it is hooked to another spaghetti noodle, the 2nd noodle comes out too, and it brings along a 3rd noodle that also drags a friend along. You get the picture? As long as you have gravity on your side, as long as the cup you are pouring into is lower than the cup you are pouring from, the noodles will continue to pull each other out of the higher cup. Hehe, Jabu, that's clever. It is, isn't it? There's other things we can try too. Try making colorful gravy goo by adding a few drops of food coloring to the water before pouring it into the cup with the gravy goo powder. Do you have any garbled marbles left? Soak them in water for a couple of hours so that they have started growing but haven't yet reached their full size. Put them in the cup of water before adding it to the gravy goo powder, and follow the regular directions in pouring the liquid back and forth. As the strings form, the gravy goo will actually link to the garbled marbles. So when the experiment is complete, the gravy goo will drag the garbled marbles along with it as it sneaks up and over the edge of the cup. Amazing. That is amazing, Jabu. When you are done, your gravy goo can be thrown away. Just be sure to not pour it down the sink. The effects of anti-gravity noodle slime on your plumbing is not an experiment you should try. That's good to know, Jabu. Super siphon. Do you know what a siphon is? Using a thin tube like a hose, you can make regular liquids like water flow uphill as well. The hose has to be filled with liquid, and one end has to be lower than the other. But then as long as there aren't any bubbles, the water will climb out of the higher jar through the tube and into the lower jar. Amazing, but only Gravigoo can do it without the tube. Here's a picture of how a siphon works. Gravity pulls the water down on the lower side and out of the tube. The water molecules like to stick together, so they follow each other through the tube. This makes an area of low pressure like a vacuum, which sucks water up out of the tube jar and up into the tube. That clever, Jabu? It sure is. Okay, let's get our things ready. Okay, Lani, we've got our 2 cups. So now let's take our little powder here. We'll take out our little blue scoop. And we've got 16 ounces of water in this one. And then we put the scoop of powder, Gravigoo powder, in that one. Alright, so unfortunately we had to cut this off because it wouldn't pop open for some reason. We need to scoop the powder here. We've got a scoop. Alright, and pour that in there to the dry one. Put that off to the side. Put the rest of this off to the side. And now we have a Chinese chopstick we're using because we didn't have a plastic cup. So, a plastic spoon, so to stir. So here what we do. Alright, so we fill the cup with 16 ounces of water. We've done that. Blue scoop out one level, scoop and pour in the second cup. We did that. And then pour the liquid from the first cup to the second cup. Use the plastic spoon to stir it gently, and then pour everything back into the first cup. And then keep pouring the liquid back and forth from one cup to the next. For the first 2 minutes you'll need to pour fairly quickly. And alright, after 2 to 3 minutes of pouring, the liquid should start to form strings of goo as you pour it back and forth. Once you see the strings, you can start pouring more slowly, but you'll need to keep pouring for about 5 more minutes. Okay, let's get to it. Pour in here. Then we'll stir it gently. Doesn't say for how long. Stir for a little bit. Okay. Ooh, it's getting gooey already. Now it says we have to pour quickly. So we'll pour quickly, right, Lani? That's pretty fast, Jabu. And it's stirred pretty good, so not doing too badly here. Wow, it's getting gooey. Look at that, hey? It's getting a little bit thicker. Can you see that, Lani? I can see it, Jabu. Wow. That's crazy. Looking slimy, hey? Wow, look how slimy it's getting. It would be cool to have food coloring, hey, Lani? It sure would, Jabu. Wow. Wow, look at that. Okay, so how long do we have to do this for once it gets clumpy like that, Lani? I forget, Jabu. I know, we'll have to look at the instructions again. Wow. But they're right, the arms do get a little bit tired, hey? They sure do, Jabu, you can tell, hey? Wow, this is crazy stuff. It is looking like clumpy, stringy beads, hey? It sure is, Jabu. Very gooey. It's gravity goo. Yeah, it's gravity goo. Or anti-gravity goo, I guess. Okay. Okay, let's read the instructions again. Let's see if we can take a break here. Okay. Alright, so after 2-3 minutes of pouring, the liquid should start to form strings of goo. Once you see the strings, you can start pouring more slowly, but you'll need to keep pouring for about 5 more minutes. You're probably pretty tired now, right? For the next step, you take a break. Your gravity goo does too. Pour it all into one cup and let it sit for 30 to 40 minutes. Well, I guess we'll have to continue pouring for a bit. We'll need to keep pouring, so we'll keep pouring for a little while. Be interesting to know why this is important, the mixing it between the 2 cups, hey Lani? I know, Jabu, it must work on the polymer somehow, right? Like it should be making it, I don't know, mixing it and creating the gooey stuff, right? Somehow it's helping the interaction work, right? Exactly, I think you're right, Lani. Maybe about just 1 more minute. Which one do you want to leave it on, Lani, when we finish this mixing? You want to leave it into the left cup or the right cup? Let's leave it on the left cup, which had the cup with the water, right? Okay, sounds good. I don't think it particularly makes a difference, but I like it. Okay, 1 more on this side, and now the last one here. Okay, try to let it all come out. Okay, Lani, we'll leave it for about 30 minutes. We'll come back in 30 minutes time and we'll show the boys and girls what's happening. Hello, boys and girls. Okay, so it's been 30 to 40 minutes. We're doing gravity goo here. And you can see we've let it rest for 30 to 40 minutes. As you can see here, now your gravity goo is ready. Let's try an experiment. Okay, so let's see what that experiment was again. Start pouring the liquid between the 2 cups again. Make sure you keep the cup you are pouring from higher than the cup you are pouring into. After you've poured the liquid back and forth a couple of times, you will notice something strange. Once you start to pour the liquid, you can't stop it. It crawls up and over the side of the cup by itself. What is it? A new alien life form? An anti-gravity slime system? A magic trick? Better, it's science. Okay, and then we know that it sort of climbs in, and we learned how that worked, right? Okay, let's give it a whirl. Wow, look at that, Lani. That's crazy, Jabu. See, it's going by itself, hey? It sure is. See, look at that. All by itself, hey? And the cup isn't even tilted, right? See, now it is. It goes all by itself. Let's try that again, see? It's very clever, Jabu. I know. Wow. Putting itself into the cup, isn't it? It sure is, Jabu. Very clever. Yeah. That's cool. Alright. What a fun experiment, hey? Okay, there we go. That was fun, wasn't it, Jabu? It sure was, Lani. I had fun with that. Hope you did too, boys and girls. That was Gravy Goo, and we had a lot of fun. We're having a ball with this lab in a bag and all these science experiments, so thanks for joining us. That's right, and come on back next time. We're going to do some more. We're going to do the 4th test tube, right? We sure will tomorrow, so we'll see you then. And remember to always take care when you're doing science experiments, but it's a lot of fun, and we encourage you to enjoy science because it's important to help our society grow and develop with technology, right? That's right, Jabu. Thanks for joining us, boys and girls, and all the would-be scientists out there. We'll see you again tomorrow. Bye-bye. Bye for now. Hello, boys and girls. Welcome to Jabulani's Playhouse. I'm Jabu, and I'm Lani, and today we're going to continue on with our lab in a bag, right, Jabu? That's right, test tube adventures. This is a lot of fun. We're on to our 4th one now, and let's see what that's got behind it, eh? Yes, please, some funny, crazy, mad scientist experiments, hey? You betcha. All right. So here we are. We're on to number 4 now. This is Little Lava Lamp. Harness the power of chemistry to make your own lava lamp in a test tube. Wow, this is going to be fun, Jabu. It sure will be. Oh, there's nothing in there, just the paper, I believe. Let's put the lid back on here. Let's have a read of this. Okay. Little lava lamp. Harness the power of chemistry to make your own lava lamp in a test tube. Just be careful that your parents don't take it to show their friends. Hehe, Jabu, that's clever. And there's the warning from the kit. This is what we need. Test tube, true colors, fizzing tablets. I guess that's what these are for, hey? Here they are. See the different colors? What does it say? 3 fizzing color tablets, 1 each of red, yellow, blue. That's fun, Jabu. Yeah, it's going to be lots of fun. And then we need a pipette, which we have. Here's our little pipette, boys and girls have seen before. And a test tube rack, which we have behind us. And then you get it stuff. We'll need vegetable oil, water, transparent disposable cups. We need 3 of them. Notebook and pencil, milk, vinegar, soda pop, or orange juice. Optional. That sounds good, Jabu. Before you start, you'll be using and pouring liquids, including vegetable oil, so work with your adult assistant to find a place to set up your laboratory where it's okay to spill a little. Okay, try it. Discovering hydrophobicity, an adventure in liquids. Pour some water into one of the plastic cups and pour some vegetable oil into a second cup. Give each a thorough investigation. Record your observations in your notebook. How are the 2 liquids alike? How are they different? You may want to draw pictures of your observations and discoveries. Keeping an accurate record of your experiments is one of the most important parts of science. Pour a little water into the first cup, into the empty third cup. Pour a little water from the first cup, into the empty third cup. Now you will use the pipette to transfer some oil from the water cup to the third cup. Before you do, practice using the pipette to figure out how hard to squeeze it. Can you make only 1 drop come out? Here's a hint. To use the pipette, pinch the bulb, lower the tip of the tube into the oil and gently release your pinch. The oil will be drawn up into the pipette. If you keep the pipette upright, the liquid will stay inside until you squeeze the bulb again. Once you've mastered the pipette, use it to transfer some oil into the third cup. Squeeze in just 1 drop. What happens to it? Squeeze in a second drop, a little to the side of the first. What happens now? What happens if you lift the pipette a little higher, a couple of inches before squeezing out a drop? What happens if you stick the pipette slightly into the water before squeezing out a drop? Carefully tip the cup a little back and forth. What do you see? Use your pipette to stir the liquids in the cup. What happens? Record your observations in your notebook. This is just the kind of thing scientists do when they make discoveries. Number 4. Carefully pour more oil into the third cup until you have about 1 inch. Now what do you see? Use the pipette to add a drop of water from the first cup into the third cup. What happens? What's going on here, Lani? I don't know, Jabu. Let's read. As you have probably figured out, oil and water are different. Why is that? Do you know what a molecule is? It is the smallest amount of something that still acts like itself. If you have already done the pH power experiment, you know that a water molecule is made of 1 oxygen and 2 hydrogen atoms stuck together. Atoms, as you may already know, are made of protons and electrons. In molecules like oil, the atoms share the electrons pretty equally. Other kinds of molecules don't share electrons very well. Some parts of the molecule pull the electrons towards themselves, leaving the other parts of the molecule electron poor. These kinds of molecules are called polar. As it turns out, polar molecules like to be around other polar molecules, and non-polar molecules, molecules that share electrons well, like to be around other non-polar molecules. Water is a very polar molecule, but oil is not, so they do not like to be around each other. They don't mix well. Still confused? I'm not so confused, Jabu. I know, that's because you're smart, Lani. Take Jabu. Think of electrons as having heat. You could imagine that people were molecules, and that there were two kinds of people. One kind of person has an equal amount of electrons in each hand, so both of their hands are pleasantly warm. Not too hot or too cold. The other type of person has all of their electrons in their right hand, so their right hand is hot, while their left hand without electrons is cold. Now imagine that the people always want to hold hands with someone else. People with nice warm hands only want to hold hands with someone else who has nice warm hands. Why change a good thing? People with one hot hand and one cold hand, though, want to hold hands with someone who also has hot and cold hands. The very hot hand of such a person will feel better when it is holding on to someone else's cold hand, and the cold hand will feel much better once it is holding on to a hot hand. Molecules are like people this way. Hot and cold handers, polar molecules, tend to find each other and stick together, while the pleasantly warm handers also stick together. Neither type likes to mix with the other, so they stay separated. This is why your oil drop stayed stuck together as a little circle on top of the water. All of the oil molecules were holding hands and trying to stay away from the water. Scientists would say that water is hydrophilic, that means water-loving, and that oil is hydrophobic, water-fearing. Of course, the molecules that make up oil and water don't really either love or fear water. They just have a tendency to mix well with water or not. Tint time. Discovering dissolving. Other kinds of molecules can be defined as being hydrophobic or hydrophilic. You can test this. Try putting a drop of milk or orange juice or soda pop in your cup of water and one in your cup of milk. What do you see? Another example of this is the molecules that make up your true color tablets. You have 3 colored tablets in your kit, a red, a yellow, and a blue. Decide which color you want your lava lamp to be and set the tablet aside for a moment. Your tablets are either hydrophobic or hydrophilic. If they are hydrophobic, they will dissolve in oil, but not water. If they're hydrophilic, they will dissolve in water, but not in oil. Which do you think it will be? Write your guess in your notebook. Now drop one tablet into the oil and one into the water. How will you know whether your tablet is hydrophobic or hydrophilic? You'll know. Record what you see on your notebook. Time to make your lava lamp. Fill the test tube with oil all the way to the overhanging lip. You may want to have your adult assistant do this step, so any spills that happen aren't your fault. Next, slowly add a little water almost to the top of the test tube. Carefully place the test tube into the test tube rack from your kit. Drop the last True Colors tablet into the test tube. What happens? Wow, a fizzing explosion. Draw or write about your observation in your notebook. When the fizzing stops, use your pipette to carefully add more oil to the very top of the test tube so that when you cap it, there will be no room for air. Cap the tube tightly and use a paper towel to wipe off any oil that's squeezed out. Tip the tube back and forth. The water looks like a weird flowing blob, doesn't it? How cool is that? Shake it up. What happens? Don't worry, your lava lamp isn't broken. If you let it set for a while, the water molecules will find each other and the oil molecules will find each other too. The oil and water will separate and hold hands once more. In fact, you can make the oil and water stay mixed. That's why your parents always have to shake up the vinaigrette dressing right before putting it on their salad. Vinegar is hydrophilic like water, so it always sinks to the bottom of the bottle after a while the oil stays on top. How does it work? Have you noticed that however many times you tip it, swirl it, or shake it, your water blob always ends up on the bottom of the tube? Why is that? Believe it or not, water is heavier than oil. Scientists would say that it is more dense. What does that mean? One way of thinking about it is that a cup of water weighs more than a cup of oil. Another way to think of it is that it would take more oil than water to weigh a pound. Because oil is less dense, it always ends up above water. How does soap work? Soap is made of molecules with both a hydrophobic region and a hydrophilic region. When you wash with soap, the hydrophobic portion of the molecules stick to and surround the hydrophobic dirt and oils on your skin or clothes. If the hydrophobic portion of a soap molecule stuck on the dirt, what do you think is sticking out on your other side? The hydrophilic portions of all the soap molecules that are surrounding the dirt are facing outward and are free to interact with water molecules, which can then surround the soap surrounded dirt, called a micelle, and wash it away. Amazing. That is pretty cool, Jabu. Let's get our stuff ready. You betcha. Okay, Lani. We have our 3 cups here. We're not using disposable ones because we want to be friends for the environment, right? Jabu, that's right. So here we have water, right? And here we have a little bit of oil. Not much, just a little bit. And here we have an empty cup, right? Exactly. So let's read what we're supposed to do here. Okay, so we've poured some of the water into the plastic and some vegetable oil into a second cup, and then it says pour a little water from the first cup into the third empty cup. So we'll do that. It says about an inch. We'll say that's about an inch, maybe not, but we'll say that's about right. Now you'll use the pipette to transfer some oil from the water cup to the third cup, which I think they mean from the oil cup to the third cup. I think that's an error. And so they said squeeze in just 1 drop, what happens to it, then squeeze in a second drop, and then what happens if you stick the pipette slightly into the water before squeezing out a drop. Okay, so let's see what happens. There we go. So let's put in a drop here, and then another drop just next to it. See how they like to join, Lani? Let's see that again, Jabu. Yeah. Okay, so you can see the oil there. So let's put one next to it. See, they'll like to join each other. Watch. The oil getting closer. They've joined up together. Put another one next to it. See how they like to join? I see that, Jabu. Clever. Then we stick this under here, we put in a drop. Another drop. Cool, hey? That's very neat. Put the oil back in there. Okay. So now it says, pour more oil into the third cup until you have about an inch. Now what do you see? Use the pipette to add a drop of water from the first cup into the third cup. What happens? Okay, let's pour all of this in because we have about half an inch, I guess. I see that the oil floats on the top, Jabu. I know. Let's put the oil, the mixed glass in the front here. You can see the oil is on the top. And then it says take some water. And what happens if you put a drop in here? Let's take a close-up. Well, it's fun, Jabu. We got lots of bubbles. Water. I know. Let's take a close-up of this and see what's happened here. Wow. That's neat, eh? You can see that the water, some water interspersed, I think, within the oil, because it's mixed up, but generally, the water is at the bottom and the oil is on the top, eh? I see that, Jabu. That's crazy. Okay, so down here it tells us what's going on, right? And we read about that, because they're called hydrophobic and hydrophilic, right? That's right, Jabu. And there's some more information as we read. You can pause it here if you want to read it again. Just show you, there you go. So you can pause that. Alright, and now, tint time, discovering, dissolving. So we're going to take our time to use the lava lamps. So decide which color you want your lava lamp to be. I want it to be blue, Jabu. Okay, so we'll set aside that particular one. You want the blue one, so we have red and yellow, though it looks like purple, but I'll take the take a word on it. So let's take the blue one. We'll take them all out, might as well, because we're going to need them. Put the blue one aside, at the back. Here we have two others. Put those up front. And it says your tablets are either hydrophobic or hydrophilic. Which do you think that it'll be? I think it'll be hydrophobic. I think it'll dissolve in oil. That's right, I think you're right. We will find out, hey? So it says drop one tablet into the oil and one into the water. How will you know whether your tablet is hydrophobic or hydrophilic? Okay, so we have to get oil. We have to put oil in the 1 cup again. Okay, so on the left we have water. It's got a couple of drops of oil in, but we won't worry about that. And on the right we just have oil. So let's put this one in here. Do you think it'll dissolve? No. Oh, it does. Let's see about this one. Aha! We were wrong, Lani. Oh no, Jabu, we were wrong. These are actually hydrophilic, right? Which means they love water. I think you're right. Exactly, you can see it's fizzing up, hey? Wow, Jabu, that's crazy. I know. That's neat, hey? Let's take a close-up of this. See what's going on here. Can you see it fizzing there? Let's have a look from the top. Okay, Lani, we're ready. You can see we got a little plastic tray to put this in because apparently I think this is going to, our lava lamp is going to fizz over, right? That's right, Jabu, so that's clever. So what we'll do is fill the test tube with oil all the way to the overhanging lip. And next, slowly add a little water almost to the top of the test tube. Then carefully place the test tube into the test tube rack from your kit. Drop the last True Colors tablet into the test tube. What happens? Wow, a fizzing explosion. Draw right about your observation in your notebook. When the fizzing stops, use your pipette to carefully add more oil to the very top of the test tube so that when you cap it, there will be no room for air. Then cap the tube tightly and use a paper towel to wipe off any oil that's squeezed out. Tip the tube back and forth. The water looks like a weird flowing blob, doesn't it? How cool is that? And then shake it up. What happens? Alright, let's check it out. Okay, Lani, we've got our paper towel ready to wipe it up. I'm going to put this in here. As you can see, we've filled it up just to the overhanging lid here, as you can see. Just up to that little lip, overhanging lip. And then it says to add water. We'll just confirm again. And it says carefully place the test tube in the test tube rack. Next, slowly add a little water almost to the top of the test tube. So we'll need to get some water. Okay, we've got fresh water here, Lani. We'll use our pipette. We'll add it almost to the top, it says. Take a couple of these pipette drops, I think. Almost to the top. Maybe a smidge more. There we go. That looks about right. And then, carefully place the test tube into the test tube rack. Drop the last True Colors tablet into the test tube. Ooh, it's going to explode. When the fizzing stops, use your pipette to carefully add more oil to the very top of the test tube so that when you cap it, there will be no room for air. Okay, so where's our little blue pill? Oh, Jabu, this will be very scary. Whoopsie, here we go. Bonk. Let's make sure this is all upright. I want it perfectly upright. There we go, that looks good. And here we go. Bonk. Now we wait, hey? It's starting to fizz. Can you see that, boys and girls, at the bottom? It's going blue. Uh-oh, here come the bubbles. Baby scary, Jabu, what's happening? Wow, there's a little lava lamp. That looks cool, hey? It does. Look at those little blue bubbles, hey? That's very cool. I love it. That's neat, hey? I guess because it's dissolving in the water and releasing some of the fizziness. And because it's hydrophilic, it doesn't like the oil, so it goes up in little bubbles of blue, hey? That's really cool. There is a little lava lamp, hey? I know. Look, some of them are coming down the side. That's neat, hey? Wow, this is a cool little experiment, hey, Lani? I love it, Jabu. It's super cool. I wonder how much longer it'll go for. I don't think all that much longer. I think the little blue sort of level at the bottom is starting to run out, I think. And I think we did it just right because it hasn't actually fizzed over, so that's perfect. Wow. That's super fun, Jabu. I love it. Yeah, me too. Very neat, hey? Our own little lava lamp, Lani. I know, Jabu, it's fun. I've always admired those lava lamps in the stores, right? In the lighting stores. I know, they're super fun. I think it's just coming to an end here fairly soon. Okay, well that just finishes up. Let's see what we do. Okay, so we cap it, add in a little bit of oil to the top, and then cap it. There will be no room for air. And then tip the tube back and forth. The water looks like a weird flowing blob, doesn't it? Shake it up, what happens? Cool, okay, so how does it work? Have you noticed that however many times you tip it, swirl it, or shake it, your water blob always ends up on the bottom of the tube? Why is that? Believe it or not, water is heavier than oil. So that's why, Lani. That's cool, Jabu. It's all finished now. Okay, so we need to get some oil. See if we can put it to the top here. Right to the top. I think just a smidgen more. I think that's about right. Put the lid on carefully. Nice and tight. Okay. Just wipe this a little bit. Now we can tip it. There's a little blob, Jabu, as they said, hey? I know. A little water blob. Let's shake it. Wow. See, we mixed it up. And over time, it will start to separate again, right? Because they don't like each other. That's right, Jabu. You're already starting to see that it's starting to separate, right? Exactly. Wow, it's a lot of fun. Okay, we'll just speed up this part for a little bit and then see how it starts to separate, hey? Separating quite well already, isn't it, Lani? You sure is, Jabu? Thanks for joining us, boys and girls. That was a fun experiment with the lava lamp, Jabu. It sure was, Lani. We had a ton of fun with it. Thanks for joining us, boys and girls. Coming back tomorrow, we're going to do the last experiment. Should be a lot of fun. Hope you've been enjoying this. We've had a ball. It's our first science experiments, right? That's right, Jabu. And it's a lot of fun, too. Makes science super interesting, doesn't it? It sure does. And I know a lot of you boys and girls out there are going to enjoy science now and want to become scientists and chemists and that, hey? That's right, those are good jobs too, aren't they? They sure are. They help society a lot. Anyway, thanks for joining us. We miss you when you're not here. We'll see you again tomorrow. Bye-bye for now. Bye-bye. Hello boys and girls, welcome back to Jabulani's Playhouse. I'm Lani and I'm Jabu, and we're going to finish up our science experiments here today. We're going to do the 5th test tube and the last test tube, right? That's right, Jabu, it's been a lot of fun so far. We've had a ball, haven't we? We sure have. We've been mad scientists. Mwahahaha. That's right, Jabu. It's been super fun. Thanks for joining us with all these experiments, boys and girls. This is Test Tube Adventures from Lab in a Bag, and be amazing, right? Exactly. So let's see what's on store today in our last experiment test tube, hey? Yes, please. All right, here we go. Ooh, garbled marbles, Lani. Ask yourself science questions as you sort these mixed up jelly jewels. Wow, that's cool, Jabu. I think they got some stuff inside, hey? Aha, they do. Those are garbled marbles in there. Let's take them out and have a look-see, hey? Alright, we'll just put the cap on, put it back for now. Okay, what do we have here, Lani? We have the fun stuff. There it is. Oh, look at these colors. Wow, these are neat, hey? These are super cool, Jabu. They're little small little marbles, hey? Garbled marbles. These are cross-linked polyacrylamide polymer gel, so these are going to grow quite large, I think. So we've done some of that before, haven't we, with our disappearing jelly ice, right? That's right, Jabu. I remember now that you mentioned it. Okay, what's going on? Let's see what we do here. Garbled marbles. Ask yourself science questions as you sort these mixed up jelly jewels. After you become an expert in your field, watch them grow to giant jelly sizes. And then we've got warnings, of course. That's right. What you'll need from the test tube: garbled marbles, multicolored beads. You get it stuff. Your notebook and pencil, assistant with good eyesight, disposable cups or bowls, and water. One of the most important aspects of all science is classification and categorization. It's how scientists make discoveries and learn about the world. From mushrooms to sharks, microbes to molecules, stars to subatomic particles, scientists figure out science secrets by first studying and sorting. They ask questions such as, how are these things alike and how are they different? You can do just this as you embark on a study of garbled marbles. Ask yourself science questions and see if you can figure out the answers. Okay, let's try it. Carefully sort the garbled marbles. How many different colors are there? How many different sizes? Will the difference in the size and color of the garbled marbles affect how big they will become or how fast they will grow? Why do you think that? Write down your guesses in your notebook. Now do the experiment to see if you were right. Fill the disposable cups or bowls with water and put the different kinds of marbles into the different cups. Let them sit for a few hours. Check in on them from time to time. What did you find out? The science name for your garbled marbles is cross-linked polyacrylamide polymer gel. It's a big name, isn't it? Did you catch the word polymer in there? A polymer is really a big molecule made up of lots of little molecules linked together, just like a train is made of many train cars linked together. In fact, the word polymer actually comes from two Greek words, poly meaning many, and meros, which means units or parts. So a polymer is a big molecule made up of many parts. In polymer science, the train cars are called monomers, which comes from the Greek words mono, one or single, and meros again. And meros, which means units or parts, right? But why does it grow in water? Garbled marbles are like nets made of lots of little molecules connected together. Because they are like a net, water can sneak inside through the holes. That is, the crystals drink, soak up water, and keep it locked inside. The polymers that make up garbled marbles belong to a class of molecules called the superabsorbents. That means that garbled marbles are thirsty, very thirsty. Each marble can hold up to 300 times its weight in water. If you were a garbled marble, you would be able to drink almost 2,000 gallons of water. Jabu, that's a lot of water. It sure is. When the garbled marble crystals meet water, they start drinking. When they soak up the water, they expand, get larger, and soften. In other words, you added water to make big squishy marbles made of goo. Jabu, that's crazy. A pearl of a marble. These jelly marbles look like transparent, colorful jelly pearls. You might be surprised to know that real pearls come in different colors as well. Do you know where real pearls come from? Pearls are made by certain bivalve mollusks, like clams and oysters. When something that irritates the mollusk gets inside the shell, the mollusk puts a coating around the irritant to protect itself. It keeps adding layers and layers of coating, making larger and larger pearls. The coating is made of the same substance that the mollusks use to line the inside of its shell, a combination of calcium carbonate and a protein called conchiolin. Although people used to just look for pearls, now pearls are usually farmed. That means that people put something into a mollusk, like a little bead, and then wait for the mollusk to layer more and more calcium chloride and conchiolin over the bead until it becomes a pearl. People that farm pearls are called aquaculturists. Other things to try. Find a place where no one will mind a bunch of jelly pearls rolling around and play the slimiest game of marbles in town. After checking with your adult assistant, hold a jelly pearl several feet off the ground and then let it go. Hey, your garbled marbles bounce. Hee Jabu, that'll be fun to try. I know. I agree. Okay. How does it work? The secret of the bounce. If you could take a picture of your jelly marble at the moment it hit the ground, you would see that it looked pretty squashed. Your marble bounces because it is made of a polymer like rubber, which is very elastic. This means that it springs back into shape after it has been deformed, squashed, or stretched. Whether you throw the marble or just drop it, a lot of energy is contained in the motion, enough so that when it hits the ground, the impact can pull or push the molecules that make up the marble out of the places they want to be. But the molecules don't want to be like that, they will fight back. In fact, they fight back so hard in putting themselves back into the places that they want to be that they push off the ground, and the marble goes flying, boing, into the air. Scientists say that substances that do this have elasticity. Other substances don't have much elasticity. Have you ever played with clay? What would happen if you made a ball out of clay and dropped it on the ground? The same amount of energy would pull the ball of clay into a squash shape, but without elasticity, the molecules just get pulled or pushed out of their original places and then just stay there, flop on the ground. What other substances do you know that have elasticity? What substances do you know that don't? Physics fun. How high will the Super Bowl fly? How much of the energy from the motion of the jelly marble gets transferred back into the bounce energy by the elasticity of the molecules? You can try it and see. Hold the jelly marble close to a wall and drop it straight down. Measure how high the jelly marble bounces on its way back up. If the jelly marble reaches as high during the bounce as it was before you dropped it, then all of the energy in the motion of the marble was transferred back into bounce energy. If the marble acts like a clay and just sticks flop to the floor, then none of the energy of motion was transferred back into bounce energy. If the marble bounces half as high, then about half of the energy was transferred back. How much bounce energy is transferred back? None, some, half, most, or all. Try this test on different surfaces. What kind of surface will allow the marble to bounce higher? A hard one like cement or a soft one like carpet or grass? I think it'll be a hard one, Jabu. I think you're right, Lani. Having trouble bouncing back? What makes the marble stop bouncing? As you probably noticed, not all of the energy from the motion of the marble gets transferred into bounce energy. Where does it go? Where do you think it goes? Some of it gets transferred to the floor where the marble hit in the form of heat. The floor will actually be a little bit warmer when the marble hits, though probably not enough for you to notice unless you had a very sensitive machine to test it. Some of the energy gets transferred to the marble itself. That very sensitive machine could probably sense that the marble gets just a little bit warmer after every bounce too. Lastly, listen very carefully when the marble hits the ground. What do you hear? Some of the energy turns into sound energy. A talking bouncy ball. How cool is that? Hee Jabu, that's lots of fun. I know. Okay, Lani, you can see we've got our little marbles there. Let's get a close-up. You can see we've got different colors, right? So we've got like dark blues, I guess, light blues, greens, clear ones. We've got 3 different colors of sort of red. We've got red and darker red and sort of an orange one. And then we've got some yellow ones too, right? That's right, Jabu. They look like a lot of fun. All right. And now we have our water, our bowl of water. We're just going to use the 1. So that'll be fun, right? There's our garbled marbles. So let's see what we've got to do again. So we sorted them, as you can tell. And what do you think the size of the color of the marbles will affect how big they will become or how fast they will grow? I think the size will make them bigger, right? If the bigger ones will be bigger, right? I think you're right. So fill the disposable cups or bowls with water and put the different kinds of marbles into the different cups. Let them sit for a few hours, checking on them from time to time. What did you find out? Sounds fun, Jabu. I know. Okay, we'll plop them all in. We're just using the one bowl. So, plonk, 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 plonk. Jabu, they're not actually making that sound. Plonk, plonk, plonk. I know, I'm making that sound for them. It's fun. See, we don't want to put all of them in. We'll probably need a huge cup because these very thirsty, they said. They can go up to 300 times their size. I think that's what it said, didn't it? I think it said something like that, Jabu. Okay, is that all of them? Alright, there they are. Let's have a look at them. Wow, Jabu, they're small right now. We'll come back and see how much bigger they got in a little while, hey? We sure will. Okay, boys and girls, so it's the next day, and we now have all our little marbles. You can see them in there, and they all look pretty much the same size. Let's take a close-up. Lots of different colors, hey? They sure are, Jabu. They look terrific, hey? They do. And they're similar sized, maybe a couple bigger ones, but roughly the same size. Let's take a close-up in our hands. Okay, so here they are. Nice little squishy marbles. Very squishy. Whoops. They bounce around a lot. Very bouncy. Let's see if they can bounce on here. So we're going to drop it from here. Hee Jabu, they bounce well. They do. They bounce really well, Jabu. I know. Let's try another one. Let's try a blue one here. Okay. They bounce really good, Jabu. I'm very happy with them. I know, me too. Wow, they worked out terrifically well, didn't they? They sure did, Jabu. Those are our little garbled marbles. And that's the end of our science experiments, isn't it? It sure is. Well, thanks for joining us, boys and girls. I hope you enjoyed that. That was a lot of fun, wasn't it, Jabu? It was terrific fun. We loved that, and hopefully we might do some more lab in the bags if we can find some, because we enjoyed the science experiments. They were a lot of fun, weren't they? They sure were, Jabu. It's crazy how big those little marbles got, hey, considering that they were so small. I know they can absorb up to 300 times their weight in water, I think, so that's terrific. Well, thanks for joining us, boys and girls, and again, we'll see you soon, and until then, we miss you. Bye-bye for now. Bye-bye.